Okay, we're looking at compound interest problems with different compounding periods now. Example 1, Natalie wishes to invest a lump sum today so that she can save $30,000 in 5 years for a European holiday. She chooses an account earning 4.8% per annum compounding annually. How much does she need to invest to ensure that she reaches her goal? Well, this is an annually one, so we don't have to go changing R and N and all that sort of stuff. But tell me, A equals P, 1 plus R to the N, what is that $30,000? Is it a P, a principal, or is it an A, the amount at the final end? How much does she need to invest to ensure that she reaches her goal? Is $30,000 A or P? A. $30,000. She wants $30,000 at the end. P is question mark. What's the interest rate? 4.8% per annum. Please get in the habit of writing the units, because then if you've underlined annually, you know you don't have to change anything, which is 4.8 over 100, which is 0.048. Right, N is 5 years. Units are the same, annually, per annum, 5 years. Great. So with compound interest, you're looking at 3 things. You're looking at the question, the compounding. If that's annually, the R needs to be annually, the N needs to be annually. All right? So A equals P, 1 plus R to the N. A is 30,000. Principal is P. 1 plus R. Can we just add those together? What's 1 plus 0.048? 1.048 to the power of 5. Now, I would not work out what that 1.048 to the 5 is, because otherwise you're going to get a decimal answer and then you've got to carry figures. Can't we just go 30,000 divided by 1.048 to the power of 5 is P? Because P times all of that gives $30,000. So P is $30,000 divided by that. And what do you get? 0.93. Now, if you've got a bit of time in an exam, you might say, right, I'm going to check if that's okay. Put this now as your principal, times it by 1.048 to the power of 5, and hope you get roughly $30,000 plus or minus a cent or two. That's how you check your answer. All right? Same problem, different compounding period. If Natalie wishes to invest a lump sum of money today so that she can save $30,000 in 5 years for a European holiday, she chooses an account earning the same interest rate but compounding monthly. Now, if she's compounding monthly, she's going to earn more interest. Just look at do you think she needs to put more or less money in if she's going to earn more interest? Remember, she's coming up with a total amount of $30,000. We're hoping a bit less. All right, let's see how we go. So over the side, the amount that she wants to reach is $30,000. The principal is question mark again. Her interest rate is 6% per annum, but you write compounding monthly. So now we know that we need to change something. Yes, it is. I don't know where I'm getting 4.8% per annum compounding monthly. So girls, what's 48 divided by 12? Yeah, it's 0.4% per month. Do you know where I got that from? I divided it by 12. So you go 4.8 divided by 12. Here, I'll go over here. 4.8 divided by 12. What are you got to do with that amount still? Have I divided it by 100? So it's 0.004 or 004. Please, it's 4.8 over 12. You still need to divide it by 100. So you should really just get your calculator and go 4.8 divided by 12 divided by 100. Got it? Don't think 0.4 is small enough. I'm not going to divide it by 100. This is interest rate for a month. N is 5 years, but my units are wrong. What do I do with it? 5 times 12, 60 months. We're happy now. Well, I am anyway. So, here we go. A equals P, 1 plus R to the N, 30,000 equals principal, 1.004 to the power of 60. So therefore P is going to be 30,000 divided by 1.004 to the power of 60. Please do not work out this 1.004 to the 60 and write it down to 10 decimal places and, all right? P is 30,000 divided by that. What do we get? So she had to put in about $120 less than before. $23,610.14. Example 3 on page 7. How long will Alana need to invest her money at 4.5% per annum, compounding annually, for it to double in value? A is, how long will Alana need to invest her money at 4.5% per annum? 4.5% per annum, compounding annually, that's good. Don't have to change anything, which is 0.045. N is question mark, how long? They're asking about the time. A, you don't, look, you can make up your own values if you want, but let's just try and be a bit more mathematical here. If the original amount is P, the final value will be 2 times P. Got it? So yes, some of you will do $100 and $200, $1,000 and $2,000. But if the original value is P, the principal, A, the final value should be 2P, 2 times P. So let's try that. So A equals P, 1 plus R to the power of N. A, the amount you want at the end is 2P, that equals P, 1.045 to the power of N. Now, I'm going to divide by P. 2P over P, okay, is 1.045 to the power of N. What's 2P divided by P? Do you know why? Because this is 2P equals P times that. So opposite of times P is divide by P. 2 is 1.045 to the power of N. Now, you haven't learned how to do logs. You can just guess and check. So, girls, do you think it's going to take a while to double your money? Don't start with N is 1 year. Start at least with 10 years. Try 10 years. And then we'll go down if we need to or up if we need to. So let's try N equals 10. Just do 1.045 to the power of 10. What do you get? Do you get 2? In other words, nowhere near enough. Got it? Nowhere near enough. Shh. N is 15. 1.93 is 16. 1.045 to the 16 is 2.02. What do you get? Etc. So, girls, what we've got is 15 will not double the money. 15 years will not double, but 16 will. So, therefore, your answer is 16 years. Because you won't get a double on your investment after 15 years. Do you get it? You must have 16 years. You need to give me the minimum amount of time. Now, 15 years won't be enough. So when you decide on your answer, you need to know the one before and the one that just goes over. And the one that just goes over is your answer. Okay. Example 4. Similar question. What interest rate is needed, compounding annually again, is needed to double Nadia's money in only 3 years? So, same question. Do you think it's going to be if it's taken 16 years to double the money at 4.5% per annum, If you want to double the money in 3 years, the interest rate's going to have to be very high. Okay? So let's have a look. So same sort of question. N is 3 years. We're compounding annually, so that's okay. You want to double the money. So the principal is P, and the amount at the end is 2P. And question mark is the rate. So we've got A equals P, 1 plus R to the N. 2P equals P, 1 plus R to the power of 3. What do we do now? 2P over P is 2, is 1 plus R to the power of 3. 2 equals 1 plus R to the power of 3. Okay. What's the opposite of cubing? What? No. Right idea. Opposite of squared is square root. Opposite of cubing is cube root. So, something cubed is 2. I wouldn't be guessing here, way too hard. 1 plus R equals the cubed root of 2. That is the opposite of cubing. So if you want 1 plus R, the inverse operation of cubing is cube root. I've swapped sides, by the way. Okay? I've swapped sides. 1 plus R is the cubed root of 2. So 1 plus R, what's the cubed root of 2? In other words, what times what is 2? I need more decimal places, please.
2, 5, 9, 9, 2.
Yeah. That's what 1 plus R is. What's R? If 1 plus R is that, yeah, it's 0. So you subtract 1. Do you get that? Which is 0.25992, etc. Girls, remember, whenever you use the A equals P, 1 plus R to the N formula, which is the compound interest formula, your R is always expressed as a decimal. So your R here, don't sit there and say that is a small interest rate. It's not. It's 25.99% to 2 decimal places, or 26% to per annum. Or, yeah. Okay, so what you might want to do now is go, oh no, that's okay. You might need 26%. 26%, I'm just going to go, approximately, per annum. We can also calculate compound interest using a table. What the table does is work out all the 1 plus R to the N bits for you. So, financial tables similar to the one shown below can be used to calculate compound interest. The table actually shows the 1 plus R to the N calculation bit for you, and all you've now got to do is multiply it by your principal, and it'll give you the final amount. So, this is not always years. This is the number of periods, and the interest rate you can see as a percentage, and the interest rate as a decimal. So let's look at our first question. Use the table above to calculate the amount if $1,800 is invested at 5.5% per annum annually for 7 years. We look at this question and we say 5.5% per annum. We can see in the table, N is 7 years. The interest rate and the N are the same period, the same units. So we just use our table, come across at N is 7, and look for R is 5.5%. And I can use it as a percent. So we come down here, and I'm circling this value here. 1.4547. Now, look at what the heading of the table says. Compound interest table. Total amount A of a $1 investment. In other words, every $1 grows to $1.45 with the extra 0.47 on the end. Every dollar grows to 1.4547. How many dollars are you investing in this question? 1800. So you just go 1800 times 1.4547. Do you get it? Shh. What do you get? Example 2, use the table above to calculate the compound interest earned when $3,500 is invested at 6% per annum. Be careful. Compounded every 6 months for 10 years. Problem? Compounding every 6 months. I do not look up 10 years 6%. What do? I divide the rate by 2. I'm looking up 3% for the 6 months. And my N is not 10, it's 10 times 2 is 20 periods of 6 months. So girls, I do not use the table for 6%, 10 years. I look at my compounding period, compounding every 6 months, 6% per annum. I've got to go rate divided by 2, N times 2. So now I look up 20 and 3%. 20 years or 20 periods, 3%. So I look it up, 20 and 3, there it is, 1.8, so 3%, 20. Not 10, 6%, that's wrong. I don't use the 1.79. So what do I get? Therefore, the amount is 3,500 times 1.8061. What do we get? 26. Guys, that seems a bit low. Yeah, that was the answer for the question before. So it's, what is it, 6,000 and 35? Interest rate, 8% per annum, compounding quarterly for 5 years. 8% per annum, compounding quarterly. You've got to divide it by 4. It's 8 over 4%, which is 2% per quarter. N is 5 years, but we just did R divided by 4. We have to do N times 4. So 5 times 4 is 20 quarters. We're looking up the table with 20 and 2%. 20 and 2%. I'll just show you quickly. Is there 1.4859. So your amount, $1,500 times 1.4859. Your answer should be about 2,000 something, because it's 1,500 times 1.5 roughly. What do you get? 228? 2,200 and? Okay, I will send you homework.